our first session will be the keynote on building a nation of industry-ready students. Taking the stage is Dr. Anubha Singh, who is the Vice-Chancellor at Alliance University.
First of all, a very warm welcome to the Higher Educational Technology Conference organized by EdTech. I also thanks all the sponsors here for organizing this conference and also inviting me to be a part of this conference. I'm immensely delighted to be here among the August gathering, and most importantly, the theme of the conference is very apt. And that's why it's important to deliberate today on building a nation of industry-ready students. It's interesting to see the kind of disruptive technology which, of course, WEF, the World Economic Forum, has coined as Industry 4.0. There's not even a single organization where discussions in the boardroom have not happened about this topic, is how do we prepare our students, right, who are in the elementary school or in universities, to see that they will be industry ready when they have to take jobs. So two important trends is something that all of us need to focus on. One, the acceleration rate at which new technologies are adopted. And the second one is new disruptive technologies causing so much of changes or disruption in the economy. Let's first look at acceleration rate. So it took about 38 years for radio to reach 50 million users globally. The same amount of time was taken 13 years for TV, 3 years for internet, 1 year for Facebook, just 9 months for Twitter, and then it goes into days, 35 days for Angry Birds and 19 days for Pokemon Geo. What does it mean? Another data that will be of interest to you is that just last year, every second, there were 3.88 million searches conducted by Google, 4.3 million videos on YouTube, 155 million emails, and the number goes on for tweets and Instagram. Again, what does it mean? It means that this was the data last year. By next year, that is by 2020, an estimated 1.7 megabytes of data will be created per second per person globally. Now, how is this data going to be managed? And always think about the implication that it has on, especially on higher education and also on the students who will have to work when they graduate. That means how do they become industry ready? But before I come to the point, I would also like to throw upon one more data point, that today about 65% students who are in elementary education, when they graduate, they'll not have, about 65% will not have the kind of jobs that are there today. So when we talk about upskilling, we have to think of the scale of the change of upskilling. That's the point here, and that's why look at the numbers here. So with such changes, of course, come new opportunities. It's not intimidating, it's exciting to look at the opportunities that these technologies are driving. And with such opportunities, there's a great deal of opportunity for students, for teachers, for faculty, and of course, the entire academia. And that's the theme of the conference today, and that's what I would like to deliberate in next few minutes. Now, if you look at what are the emerging sectors, again, well, there are various perceptions here, but if you look at the WEF, again, Economic Forum report, these are 12 clusters of technology which are spawning novel categories, artificial intelligence and robotics being very important there. But in addition to that, new computing technologies, 3D printing and additive manufacturing, biotechnologies, advanced materials, neurotechnology, blockchain and DLT, Internet of Things, virtual and augmented reality, and so on. Now, if you look at some of these, when we were looking at data, for example, in first few slides, now what are researchers doing and what are new things that are coming up which students are learning in university campuses, especially in some parts of the globe, is, for example, DNA data storage. Now, this will be there for 40,000 years, 45,000 years. We don't have to have flash drives to put up our presentations, and all that data will be stored in something like DNA data storage devices. So what does it mean? I'm just taking one example for the paucity of time, cannot deliberate in all the 12 clusters here, that these world-changing technologies are poised to rattle the status quo of higher education and also the jobs. So let's deliberate on the point today, or on the theme today, about higher education. So how can we teach differently? What is driving change? Or in terms of skills, technology, and of course knowledge, and how often will students need to update their skills? So it's not just traditional classroom teaching, but if you look at learning, or upskilling as we call it, it's not just one technology or one particular skill. It has almost become a lifelong learning concept. And what topics do students value most? Well, we educators talk about how to teach, what should be the pedagogy. The industry drives and the technology drives the new technology that students should learn, but where is the focus on students' motivation? So what topics do students value most? These are some of the key factors that all of us must pay attention to, especially in terms of what these changes mean to pedagogy, especially to our students who can relate it to their passion. And of course, are our teachers upskilled to teach this? Are communities ready to accept these changes? And how do we serve the entire society? Well, when the world is reinventing itself in a quicker order, all of us, students, faculty, administrators, industry, we do need to reinvent ourselves along with it. So it's not just students who need to learn, who need to study, and who need to upskill. It's the entire ecosystem of academia, communities, society, and industry, which needs to reinvent. And that again is not just few clusters of technology. It keeps changing. You have seen the acceleration in the first slide itself. So, a few examples here, especially in the higher education sector. This was a couple of years back. Again, it's happening more in advanced way in a conference like this, way back in 2017 in the Middle East. You would have seen this, that Sophia on a robot, of course, a human-like robot, was granted citizenship by Saudi Arabia. Sorry, I'll go back. And this was in a conference in Riyadh, and she, of course, gave a very impressive talk, and there were Q&A sessions. What I'm trying to tell you is that what we are doing here face to face, it's possible that these conferences, all of us would cyber commute to attend these conferences, and technology would be such that while commuting, the handshakes will feel like real. Now, again, look at the pace with which it is changing. In a classroom setup, again, Bina 48, a robot, of course, completed a course taught by Professor William. This is in a university in California, and this again was 2 years back. So this data, both the examples, when I'm talking about 2 years back, imagine what's happening now, at least in these part of the world. And today, though we say that Bangalore is the Silicon Valley of India, look at what's happening in colleges and universities, and are we preparing our students to compete in a world like this, which has become truly global? Some other examples here again. Lift Lab, this was a startup, actually a student project, student who was studying in Michigan, started with a project, then finally became a startup, and then of course Google bought the startup, where it's a small device, and I'm sure in all campuses our students do work on innovative projects, and some of these products also, they look at how can they then scale it up as a business plan, and then they also start startups. But then innovation is very important here, where innovation is also focusing on human value and human life. And that was one of the core themes that was highlighted by the World Economic Forum in Industry 4.0. So let's not forget that though disruptive technology is changing the higher education landscape, is changing the job scenario, but then the focus is also on human values. How do we create it for better human values in the entire ecosystem of higher education landscape? Another example here, which is a flying 3D printer drone student project, Imperial College London. Students of civil engineering designed this particular drone, which goes on the construction site, and then prints equipments for construction. So again, that's what's happening in some of these campuses. Well, two views which are a little misleading, which we have to keep in mind, is that technologies are out of our control and determine the future. Not really. Technologies are mere tools, and they are value neutral. They don't control our future. They don't determine our future. Of course, we need to upskill ourselves, train our faculty, and then finally impart this knowledge to students to do this. And for that, the first key aspect here is education curriculum. So if you look at how do we have the value embedded mindset, technological mindset in our system, let's revisit our curriculum. Two, we also need to prioritize that, especially at the top level, at the management level, and make some very important decisions on paying attention, focus, and almost making it a necessity that the entire, again, I'll use the word ecosystem of higher education, whether it is administrators, irrespective of how away they are from the technology, maybe because of the ease of use, that it is important and that we must focus on this. The third one is operational methodology. It's okay, it's very simple or sometimes easy to make decisions. But as you know, strategy is important, but what's most important is implementation part. So all the higher education institutions must have an operational methodology in place. An operational methodology in place for two things. One, how do we continuously upskill our faculty and staff so that they can impart knowledge to, and of course, skills to students. And for that, it's not just campus-driven activity. Partnering with other institutions, organizations, small and new startups which are focusing on these disruptive 12 clusters of technology, as you would have seen, is important. And to do that, the fourth important point is to have an economic incentive structure that will drive this system, and there will be motivation, because change is, people are resistant to change. Change is the most difficult thing. to make it happen at all level in any institution, especially educational institution. And therefore, an economic incentive structure is very important. Which also means that, finally, if you look at experiential learning or collaborating with, let's say, a learning management system, which is, again, advanced technology driven, how do you make that as a product and embed it into your day-to-day classroom teaching is important. And that's what is meant by product design in this context. So what is important is we as higher education leaders also have to have a technical architecture in our educational system to see that we make our students ready for the job market out there. Yes, there will be societal resistance. Sometimes simple things like, well, this is not there in campus and it's important that we maintain our culture. There will be small community resistances as well. But then if you look at the analogy of how these technologies changing our day-to-day life, it's easy to do that. Which also means that at one aspect, we have to have important new advanced hard skills, but then softer practical skills are also important. If you look at what are the requirements of 21st century job market, of course, it's the intellectual capital, but at the same time, the industry is focusing on shallow generalist, okay? Not deep specialist. That means, in addition to having hard skills and soft skills, it's important to learn to solve problems. The job market today is taking about, if you look at the focus of where employers are putting weightage, especially when they recruit, 1/3 skills is focusing on problem-solving skills. 1 in 5 must know how to have strong, deep negotiation and collaborative skills. Now remember, these two are very tricky things to have it in one person. You have to have strong negotiation skill, not to be argumentative, but to collaborate. At the same time, developing deep cognitive skills, creativity, and of course, mathematical reasoning. Because data is the new oil. I'll skip a slide here. If you look at the first 2 slides, it was all about data. What does it mean? It means that we need to store or we need to process enormous amount of information to make a simple decision. And that has become a part of everyday life. For a simple decision, you need to, if you look at the technology, if you look at the CRM that educational technology have, there's so much of data sitting at you on just one screen. And you got to look at it and then, importantly, make a decision, which means that we need to train our students to have analytical agility. It's not just data science and knowing the harder skills, which is important, but also to have the agility to make decisions from that is something that our students need to learn. And that has to become almost a day-to-day activity. We focused on 12 clusters. One which also relates to human value is neurotechnologies. If you look at an example here, I'm sure some of you would know about this, but I thought it's worth mentioning to this gathering, is Rodrigo Mendes. He was the first person to drive Formula 1 car with his mind. And again, a very simple technology which many users use to monitor their sleep. Youth or the younger generation uses it to manage or at least to play or enhance their gaming activities. It's a controlling object using, of course, computer interfaces. Let's look at it. Sorry.
For the first time, a quadriplegic drove a race car with mind control. To enhance awareness, we built a very special car.
Não. Você tá brincando.
Our innovation team combined EEG brain power technology with steering algorithms and track mapping.
O carro tem um computador de bordo que traduz esses pensamentos para comandos efetivos do carro. E consegue atuar em todos os elementos mecânicos do carro.
Direita. Acelera. Uau.
And we had speed, temperature, and heart rate controls.
It doesn't have pedals, it doesn't have a steering wheel, it doesn't have anything. It's just him and his mind driving it forward. It blew my mind.
Well, this is just one small example. So what's important for us to now focus on is, so how do we tell our students to create and execute learning goals, depending on their passion, their interest, of course. At the end of the academic year, they need to see where they should be. That means, beginning of the semester or beginning of the academic year, they have to assess their competency gaps, focus on learning objectives not just the harder skills, but also how does it relate to the softer part, especially creating human values through innovative technology, and moving beyond their comfort zones and moving into a learning zone. This is the hardest part that all of us face because they have their own lifestyle, own way of learning, though they know that the objective that they are in a campus is primarily for learning. But then, if you look at the TSU principle, which focuses on 7 practices and mindset, focus on growth. When I say growth, this is primarily, if you have read a book by Carol Dweck, which talks about fixed mindsets and growth mindsets. That's what it's talking about here, to have a growth mindset, not a fixed mindset. And then to become a serial master. That means identify what is their real strength. Just go on building that strength so that they stand out with that particular strength. Though we say that, yes, being shallow generalist is important, but then becoming a serial master in one of the strengths is also very important. They need to work hard. So we kind of encourage them, motivate them, and inspire them to stretch. At the same time, they should also see that they build their own network. Network with industry, network with academia, and of course, people in the society. It's important that each one of us, especially as students, own our own developmental journey. It's very important because it's not that, yes, there is a system which gives that opportunity, but at the same time, it's primarily the individual who has to own it. So process ownership, it's not just process ownership, but owning the entire development journey is important. Find the passion, find your passion in what I would say 12 clusters is closest to your heart so that you can do what you love. And of course, learn every day, stay vital, lifelong learning is the key. Applying these rules of reason, findings of science and new science every day, but at the same time not forgetting the aesthetics of arts, the creativity spark, the imaginative excitement is something that the higher education needs today. Thank you very much.